And now RDT 1.0, the generation number 1, right? So in this generation, yeah, the assumption is very strong. We're simply assuming that the underlying channel is reliable. As a result, sending side of RDT, receiving side of RDT, there's nothing really needs to be done. So the machine is very simple. So this RDT 1.0 is just so that you are more familiar with the finite state machine notation, right? So underlying channel is perfect. No bit error, no lost packets. Okay, so the sender side of the finite state machine, FSM, will look just like this. Okay, so there's always at least one state that is also the starting state. There's no ending state for these machines because they'll be looping forever. Okay, so starting state is wait for call from above. Okay, so application calling data to be sent to the transport layer. So yeah, calling from application from the sending process is RDT send, isn't it? So when you run into this event, the sender there, yeah, would generate packet out of data. So data is the thing coming from the application, and packet is generated to be pushed down. And to push down, we call UDT send. All right. So this is the FSM at the sender side. Similarly, at the receiver side, call from below. Right, so when that is happening, yeah, RDT receive being called, receiver side of the RDT 1.0 will just extract data out of the packet and deliver the data up to the application layer. All right, so again, events triggering changing of state, and the arc direction indicates which state it changes to. And so a loop coming back is saying that, hey, we stay at the same state. Right? In the meantime, we take these actions. So event triggering the transition. In the meantime, we make the transition take these actions. So you see, sender side keep being triggered from the application, calling this and triggering actions to occur, triggering the state being changed. Right. So that is the general idea of FSM and using it to denote a functioning machine. All right. Sender sends data into the underlying channel. Yeah, here. Receiver sends data from underlying channel. Yeah, here. All right. And then RDT 2.0. So this is when the channel is no longer perfect, but it's not so bad either. We do have some problem, but just this problem, having bit errors, meaning the packets, okay, if you look inside, some of the bits might be flipped. Therefore, it failed passing the checksum at the receiver. So the computed checksum and the packet header checksum somehow didn't match. Receiver then detect bit error. The question is, how do we recover from this error? Well, you know, if you're thinking how to do this in the computer in the transport layer, I'm sure that it's very hard. But if you think this, how do humans recover from errors during conversation? Say, if Polly was trying to describe finite state machine and it sounded really fuzzy to you, what would you do? There you go, right? You type up in the live chat and ask, hey, what do you mean transition? What do you mean changing from state to another state? What do you mean certain event occur and triggering the changing of the state? It's not clear. And Polly then will try to explain again, right? Retransmit the packet again. So, sure, if you abstract this exchange of feedback and data and retransmission, you see the general idea seems to be receiver upon detecting error sending feedback to the sender. Sender retransmit the packet again, and hopefully the second time it's clear, no longer fuzzy. That is the general idea of RDT 2.0. So to describe RDT 2.0 a bit more formally, those feedback you're providing to me, in the computer system, they'll be either in this form or this form. So acknowledgement there is a positive feedback. Negative acknowledgements, therefore, the negative feedback. Acknowledgements there or acts there are to explicitly telling the sender everything is all right. And next here is to tell the sender, something's wrong, and therefore the sender can retransmit the packet. Okay, so retransmit of the packet is triggered by the receiving of next. This is exactly what's defined in RDT 2.0. So let me stress, there's first, detecting error, second, sending back of the feedback from the receiver, and then retransmission of packet coming from the sender in case negative acknowledgement is received. Now, what's a little bit harder is to go over RDT 2.0's finite state machine. All right. Now, try to be a bit patient here. Let's focus on the sender side of the FSM first. This time, we do have two states. One is wait for call from above. Okay, this one is familiar, right? So this is the initial state. The sender is waiting for the application process to send data down to the transport layer. Okay, so wait for call from above. And there's going to be a transition triggered by this event, RDT send, the application calling and having data to send. The sender here, transport layer, will then create packets from data. And this time, in order to detect error, we need to add the checksum. Right? So, hey, this is very abstract, but you get the idea. When you're generating the packet, we do need the data from the application layer, but we also need to compute the checksum. All right, so when we generate the segment, make sure that the checksum is somewhere in the header. Very good. So send packet is finally generated. So this is the segment. And sending side of the transport layer service calls UDT send to send the segment out through the underlying channel, right? And that also take the sender from the wait for call from above state to the what? Wait for act or next state. Oh yeah, so after we send the data out, then we'll be waiting for feedback from the receiver. Good, makes sense. All right. Now, hey, here, what's coming back as feedback could be positive and negative. So therefore, you see two transitions possible, one over here and the other over here. So this is the negative feedback case, and this is the positive feedback case. Now, the easier one is if the feedback coming back is positive, right? So this is when the sender receives a message back from the network layer, so it needs to be triggered by call from below, RDT receive, the receive packet. And you check whether the receive packet is positive. So if both conditions true, then hey, do nothing. So this is empty set, do nothing, and then return to wait for call from above state. Meaning, hey, positive feedback, so move on with the lecture, for example, so to speak. Right? So, hey, Polly can actually teach more next. But if the feedback is negative, so if some of you say, hey, wait, no, not clear. Can you do this again? Can you talk about it again? Well, in that case, okay, RDT receive, called, and the feedback is negative, what? Yeah, Polly resend the packet. So UDT send, the packet that's generated being sent already once will be, sent once again. Okay, so it's a retransmission. Now, what's a bit interesting is this. When we're at the wait for act next state, when we receive a negative feedback, we actually come back here again to wait for feedback. So hopefully the next one is going to be acknowledgement, and therefore we can leave the waiting for feedback state. All right. So that was sender side of RDT 2.0, the finite state machine. Now let's move to the receiver side. All right. Whew. There's only one state, cool. But there are two different transitions, one above, the other below. So they are both triggered by RDT receive. So receiver there would be, call from below, from the network layer, saying that network layer, I'm here and I got the segment for you. I got a datagram for you. All right. And then you grab the datagram, remove the IP header, and you see the segment. You try to do the checksum computation, isn't it? Right? And there are two different conditions. One is if the packet does have bit error, meaning the packet is corrupted, then you need to do what? Send the negative feedback. So UDT send. So UDT send is what? To send the data down to the network layer. And so receiver there sending the data down to the network layer. Network layer is going to send it back to the sender. So UDT send NAC is the action being triggered. And receiver comes back to wait for call from below. So it could be a correct data packet. It could be a incorrect data packet, depending on which is the case. So incorrect calls this arc. Correct calls this arc. If it's not corrupted, extract the packet. Okay, extract the data out of the packet, deliver the data up to the receiving process, okay, and then send back positive acknowledgement. All right. So sending feedback. But if everything is correct, the receiving part of the transport layer, receiving part of RDT 2.0 is yet to extract data and pass it further up to the application layer. Okay. Now, let's walk through a couple examples to show you how the sending side and the receiving side of RDT interacts. Okay, so this is RDT 2.0. And this is an example showing that, hey, there's no bit error in the packets. So, originally, okay, the sender starts from the initial state, wait for call from above. Receiver here also, yeah, starting here, wait for call from below. All right, so now we get a call from above. Okay, RDT send being called from the application layer, the sending process. Now, sender side would actually take the data, add the checksum, and create a packet, send packet, and then call the UDT send to send it out. All right, so go through that, and that packet is going to arrive at the receiver end. Receiver side of RDT 2.0 will be called. Okay, but there's no error. Okay, so this is the no error case, so it's going to pass this condition. Receiving a packet from below and it's not corrupted, therefore triggering these actions being taken. Data extracted out of the receive packet, delivered to the receiving process, and send back in positive acknowledgement. So let me remove the notes. Yeah, so we'll be triggering this transition and all these actions, and that message is going to come back here. Okay, so you see it flashes, but essentially we were waiting here, right? And that packet, egg packet, is true. Therefore, both together is true. And we do nothing and simply return to wait for call from above. So this is the case between the interactions of the sender, RDT 2.0, and the receiver, RDT 2.0. Okay, let's do it again. Oops. Okay. At the beginning, here, starting state, here. Sender gets call from above, triggering these actions, taking a transition. And message is going to reach receiver here. Okay, and it matches this condition. Therefore, these are going to be triggered and we stay in the wait for call from below state. And this is going to generate a message being sent back this way. Yeah, and because it's an ACK, therefore we trigger this transition and the sender goes back to wait for call from above state. All right, so this is the no error example. The next example is more interesting, where there is error. All right. So similarly, sender starting from wait for call from above state, receiver starts from the wait for call from below state. And yeah, there's a call coming in. Okay, generating the packet, send the packet out through the network layer. Straightforward. So this event match and these actions taken, and we take a transition and move to the wait for ACK or NACK state. And that's going to generate a packet to the receiver. And this time, yeah, this event is triggered. Network layer says, I have a packet for you. And which of the condition matches? Well, we have error here this time, so it's corrupt. Therefore, we trigger this transition to occur. Condition match and this action, and then stay in the same state. So we'll be calling UDT send, and we are sending a negative feedback, the NACK. That's gonna fly back. So sender here waiting in the ACK, waiting for ACK or NACK state, then gets a call from below, and it's checking and finds that it's a NACK, not the ACK. Therefore, this transition matches and being triggered. This action is being taken. So UDT send packet is what? Retransmission of the send packet generated earlier. Okay, and sender here stay in the wait for ACK or NACK state. So this is taken and packets being sent again. But the second time, yeah, we're lucky. Second time it's not corrupted, therefore we trigger this transition and another packet being sent back. And this transition now, because of the condition being matching, yeah, we do nothing and we return. The sender returns to wait for call from above state. All right, should we do it again? Probably not, right? You get the idea. Okay, so the interaction between the sending and the receiving machines of RDT 2.0, how they interact. Okay, so there are actions being triggered, and in the meantime, packets being generated, and they would go to the other end, and feedback being generated, coming back to the other end.